Good morning, folks. So it's my day to be in school today, so that's exciting, isn't it? Different background. You'll notice I've got my Norwich City hat on, but that's not so much because they're the greatest football team on the planet, not necessarily in terms of results, but just to spare us all the sight of the full glow off my nice shiny bald head. Anyway, we're back on functions today, so we're going to do one example of this. The questions for you to do today come courtesy of everyone's favourite free maths website, Maths Genie. So we're going to be doing question 5 of the functions sheets, which you'll find with it, and then I would like you to have a go at questions 1 to 4 and 6. After that, we've got some modular stuff going on it. Don't worry about questions 7 and 8 yet, but if you've printed it off, don't throw those bits of paper away. They'll come in useful later on next week. Right, so here's question 5, which is the stuff that we're looking at today. It's all about when they want to know about the range and the domain. So just as a reminder, if instead of being the function of x, it was y, the range is all the values that y can take, and the domain is all the numbers you can put into the function in the first place, which is all the values that x can take. So the range of this, y is going to be able to take any value, whatever, almost. But what I would always say is, take the load off your brain a little bit, get yourself stuck into it. If you are confused at any time, whack it into the calculator, into the graphing function, hit draw, and this gives us an idea. So now, looking at this, we can see that y goes bigger up to infinity there, down up to infinity there. There's an asymptote there, but that's only ruling out -2 as an x value, which is why we have got this written here. So the domain is all real numbers, but not -2. Now the range is going to be quite similar because we've got all real numbers, but we don't have this asymptote here, which is, it looks like it's 0. Is it 0? If you think about it, the bigger x get, as x tends to infinity, y is going to get closer and closer to 0. So as we don't actually have infinite, we can't really sort of go there, so that's why we can't have 0. So the range, we can write down, can take, so this is saying that the function of x can take all real values. So we need that funny r there. The important thing is you put that second line on there and there. Don't worry too much about that sloping one. As long as you've got that, they will know what you're talking about. And then what you can't have, not x, is the function of x. Not quite right to put y because it's not called y here. Cannot be 0. Right, have a little look at part B. Find an expression for the inverse function and state its domain. So we did this yesterday. This is where we say let the f of x equal y. So we can say y equals 1 over x plus 2, and then we're just rearranging to make x the subject of the formula. So that's going to give us y x plus 2 like that. Divide by 1, y, and then take 2, and we get x is equal to 1 over y minus 2, and therefore we can say that the inverse function is going to be 1 over x. You just replace the y with the x at the end, take 2. Now if you looked at the solutions that you can find online from Maths Genie, he ends up with, oh, it might be she, I don't know, they end up with 1 minus 2x over x, and that's actually the same thing. That goes into our sort of partial fractions thing, doesn't it? Because that you could split into 1 minus 2x over x, the same denominator, and then that would cancel there. So it is the same thing. And we need to state its domain. So the range is the values it can take. The domain is the values of x we're allowed to put in. Now the value of x that we can't put in and make any sense is going to be 0, isn't it? Because 1 I can't divide by 0. So we can say the domain is going to be the domain is going to be x could be all real numbers, but it cannot be 0. Okay, on to part C. So at this point we are being told that we've got a composite function is being equal to a half. So we need to do the composite function first of all. So it's the one closest to the bracket. So you're putting x first into g and then into f. If you put x into g, you're going to get x squared minus 5. Then you're going to put that in as your x value within f. So we can say that the composite function is going to equal 1 over, instead of x, x squared take 5 plus 2. And that we can simplify to x squared take 1 over x squared take 3. Now we've got to solve that equaling a half. So if I multiply by the bottom here and the bottom there, 2 times both sides is going to give me 2 on the top. X squared minus 3 times both sides, we times 1 by that, is going to give us x squared minus 3. If you like, you can do it one stage at a time, but then all we've got to do is add 3 to both sides to get us 5 is equal to x squared, and then x is going to be the square root of 5, remembering that it's plus or minus the square root of 5. And that's the example done for today. So remember, download those the rest of those questions, and it's at Maths Genie. If you want, you can check out the solutions as well and upload some information to show me how you've got on with that. So it's questions 1 to 4 and 6 as well. Enjoy.